Have you ever pondered the impact of artificial intelligence in the realm of scientific research? This isn't just about computers doing calculations faster, it's about a seismic shift in how we explore and understand our world. From the depths of the ocean to the farthest reaches of space, AI is revolutionizing scientific fields. Consider the role of machine learning algorithms. These digital dynamos sift through mountains of data, spotting patterns and connections that might take human researchers years to discover. They're accelerating our pace of discovery, turning what once was a marathon into a sprint. Then there's predictive modeling, an AI capability that's transforming disciplines across the board. Using complex algorithms, AI can make educated predictions about everything from climate change to disease spread, helping researchers stay one step ahead. Indeed, AI is not just a tool, but a game changer in scientific research. Let's delve into a real-world application of AI in science. Ever heard of NASA's Kepler Space Telescope? This remarkable piece of technology has been instrumental in the discovery of exoplanets, planets that exist outside our solar system. But how does AI fit into this picture? Well, the telescope generates a staggering amount of data, far too much for any human to comb through. Here's where machine learning algorithms come into play. These algorithms sift through the data, searching for minute dips in starlight that could indicate a planet passing in front of a star. This process, known as transit method, is one of the primary ways we detect exoplanets. The AI does not tire and can work around the clock, analyzing data far more quickly and accurately than a human could. It's like having an army of tireless astronomers at our disposal, enabling us to make discoveries at an unprecedented rate. Without AI, such a discovery might have taken years, if not decades, to accomplish. Now, let's journey from outer space to the minutiae of human health. Artificial intelligence, in the sphere of medicine, is akin to a supercharged microscope, capable of discerning patterns and risks invisible to the human eye. It's all about predictive modeling. This involves AI algorithms sifting through vast amounts of data, from lifestyle factors to genetic markers, to predict the likelihood of diseases like diabetes or heart disease. Imagine a world where your doctor can assess your health risks accurately, using a dataset far more comprehensive than a mere annual checkup could provide. The power of AI in medicine lies in its ability to anticipate, to provide early warnings that could lead to preventive measures. This is not about replacing doctors, but about empowering them with tools that can save lives. Our journey through the cosmos of AI applications in scientific research brings us to this realization. Clearly, AI's role in scientific research is not just significant but transformative.